Hi everyone. In this video, we are going to take a look at the problem of normal distribution and also how to find the interquartile range IQR, Q1, and Q3. Okay, the amount of time that people spend at Rover Hot Springs is normally distributed. So we are told that this is the problem of the normal distribution, with the mean of 69 minutes and the standard deviation of 15 minutes. Suppose one person at the hot springs is randomly chosen, and let X to be the amount of time that person spends at Rover Hot Springs. Route all the answers to 4 decimal places where possible. What is the distribution of X? So X is a random variable which represents the amount of time that person spends at Rover Hot Springs. And we were told that this is normally distributed. So this is a normal distribution, and the way we write this is we use X and then the normal distribution with the mean. The first spot is the mean and the second spot is the standard deviation. And the mean here, it is given as 69 minutes and the standard deviation is 15 minutes. Okay, the N stands for the normal distribution. Next question. Find the probability that a randomly selected person at the hot springs stays longer than 84 minutes. So we are looking for the probability that the random variable is longer than 84 minutes or bigger than 84 minutes. So we know that this is a normal distribution, right? So it has to be the bell curve. So I can draw the bell curve like this, the bell curve, and the mean is the middle value. We have 69 for the mean, but I'm looking for the probability of the X to be bigger than 84. 84 is above 69. So it is here, right? So you want anything bigger than that. So finding the probability of the normal distribution is the same thing as looking for the area under the curve bigger than 84. So I'm looking for all the area to the right side of 84. And finding the area of all the value bigger than 84, we can use any graphing calculator. In this case, I'm using the TI-84 calculator. And we use the functions normal CDF to find the area under the curve. So we put in the lower limit. So in this case, we start from 84 and then we go all the way to the upper limit. We want to go all the way to infinity, right? All the way to the right. So in this case, I can just put 10 to the 99 power, which represents a very huge value because we don't have the infinity symbol on the calculator. So we just input a very huge value for the upper bound. And then the next input should be the mean, which is 69 in this case. And then the last spot would be the standard deviation, 15. If you input this command on your TI graphing calculator, you should be able to get the area under the curve, which is the probability of the person staying longer than 84 minutes. All right, now I can do that here. So we can open the TI-84 and you can use the function stat here. Click on stat and actually not quit. You should quit here. We're gonna use the distribution instead. So second var to get to the distribution, and this is the normal distribution. So normal CDF, which finding the area under the curve. So I hit enter, and my lower bound, I start from 84 and I go all the way to the upper, so I can put like 10 to the 99 power, or you can just simply put 99999. This just represents a very large value. And then the mean is 69 in this case, and the standard deviation is 15 in this case. And you just paste everything in the formula, hit enter again, and you should get 0.1587. Let's round it the 6 to 7 because the 5 is equal to 5 here. So we have 1587. So 0.1587 to 4 decimal places, or this is 15.87% change. Next question. The Park Service is considering offering a discount for the 7% of their patrons who spends the least time at the hot springs. What is the longest amount of time a patron can spend at the hot springs and still receive the discount? Okay, so in this problem, we are told that, again, this is the normal distributions, and we have 7% of their patrons. So that would be right here, 7%. 7% in decimal value is 0.07. So this is 0.077%. And we are asked what is the longest amount of time. That means what is this value, right? What is this value? Because this is the highest point. So this is the time. You remember we have the center, the mean value 69. So what is the longest value right here? Okay, in minutes. All right, so in this case, we are given the area and we want to find the time here, or the x value. So again, we can always use the graphing calculator. We will go to second distribution again, but in this time we use the function inverse norm, right? So I'm going to put inverse norm, the function, because we are doing the reverse process of what we did before. We are given the area and we want to find the value on the x-axis. We use the inverse norm. So what the inputs do we put here? So normally for the inverse norm, we'll take the value on the left side of the question marks. So whatever the value that I'm looking here, I need to input all the area on the left side of that location, which is 0.07. And then I put in still the mean 69 and the standard deviation is 15. And let's do that. We have inverse norm and we have the area. The area is 0.07 and the mean 69. The standard deviation is 15 and we hit enter. We have 46.86. Okay, 46.86. So we have 46.86 minutes. Okay, 46.86 minutes. And that is the longest amount of time a patron can spend at the hot springs and still receive the discount. Now, the last part, we are asked to find the interquartile range IQR for the time spent at the hot springs. So, what is the definition of the IQR? The IQR is just the middle 50% of all the data value. Or IQR is in fact equal to Q3 minus Q1. So we simply need to find what are Q1 and Q3 and then do the subtractions. Alright, so again, this is the normal distribution. We have a normal curve. We have the value in the middle 69 because of the mean. And Q1, what is Q1? Q1 is the first quartile, or the first 25% of all the data value. So this is all the way from here up to the 25%, 1/4 of the data value. So 25% is 0.25. So I have 0.25 here. So what happens if I have the area of 0.25, and what should be the value here? What is that Q1? Q1 is the value here, which gives me 25% of the data. All right, so this is the same problem with the last one. We are given the area and we want to find the value on the x-axis. So again, I use the inverse norm formula. I input the area to the left side of that location, and then I input the mean and the standard deviation. The mean is 69, the standard deviation sigma is 15. And then I should get the value. Let's do that here. We have second distribution, and we go to inverse norm, and we put in 0.25, and we have 69, 15 still, and we'll get 58.88. So 58.88. And then the next one, we want to find Q3. Q3 is the 75%, the location of the 75 percentile. This is the middle value, which is 50 percentile. So 75% is would be around here, right? Q3. I don't know that value, but I know that all the value on the left side of Q3, it has to be 0.75 because of the 75 percentile, right? And all the values before Q3. So I will also use the inverse norm function, and I input 0.75 because that is the area on the left side of the location that I'm looking for that value. And then again, 69 is the mean, 15 is the standard deviation, and we again use the second distribution, and then go to inverse norm. The same thing, except we change this one to 0.75, and we get 79.12 if I round this one to 2 due to the 7 after, right? So 79.12. 79.12, and I have here 58.88 minus 79.12. So IQR, we simply take the Q3, 79.12 minus Q1, 58.88. Okay, and we will do the subtraction. 79.12 subtract 58.58, and that would be 20.24. Okay, so 20.24 minutes. This is the IQR of the problem. And one last thing is, don't forget that the problem asks you to route all the answer to 4 decimal places. So at this step here, we should have routed to the 4 decimal places. So I can quickly show you that here again. This is 0.07. So instead of writing only 2 decimal places, you can have 4 decimal places. So 46.86, and then you can include 3-1 to make it 4 decimal places. And then you can do the same thing here, and then keep it 4 decimal places because the problem wants that. And that should be all for this problem. And thanks for watching.